guys. So let's start our new chapter. Okay. As usual, we're going to spend 2 weeks on this chapter, and this one is on efficiency. Okay. Efficiency. So what we're going to do in this chapter is we're going to look at demand and supply and more details of it again. Okay. So this semester and even next semester, that chapter number 3 of demand and supply is going to be really useful. So efficiency is basically kind of related to questioning how do we allocate resources without too much waste, right? Without too much loss, without too much waste, without too much loss. So let's say we have some resource. Let's say we have 20 hungry people, and I have, I don't know, let's say 10 slices of pizza. It's a resource, right? There is a way to distribute this resource, right? One way could be, I don't know, just share equally, half a slice of pizza each. There are 20 hungry people here, right? Or maybe we can have some competition. People who can answer the questions correctly get a slice of pizza or 2. Those who can't don't get anything. Or just a lottery. Turn on the computer, generate some random numbers based on the student numbers, and provide this resource in this way. So there are many different ways of allocating the resources, right? Or like command, for example. Oh, okay, because for whatever reason, I give you 3 slices of pizza. You're going to give 2, the rest is for you, and everybody else goes hungry. It's a command economy, say something that's happening in North Korea, for example, right? So this simple idea can also be generalized to the whole economy, to the whole country, right? And one way of allocating the resources, another way of allocating the resources is based on your own benefit from this resource, right? I think it's somehow related to the market economy, where we pay for things rather than command economy. Right? Market, as we mentioned, like I mentioned, this kind of a very interesting feature of the market, the invisible hand of the market. Remember when I gave you the example of going for lunch to the Ida Mall, right? How come there is enough food for all of us, right? Even though we didn't actually have to exchange hundreds of emails beforehand, hundreds of customers, perhaps thousands of customers, right? And dozens of food vendors in the mall. Did we have to exchange emails among all of hundreds of us to make sure that there will be enough food tomorrow, right? The market allocates the resources in some way. Whether it's efficient or not, we can have a look at that during the next couple of weeks, right? But that's just like a lottery, just like the command economy, just like some kind of competition. It's just another way of allocating the resources. The vendors do have the resources, right? And perhaps, maybe the market is creating incentives for them to make sure those resources are available for us. That's why the food is there, even though we didn't have to exchange emails to make sure the food will be there, right? Because they want to get the profits, we want to get the food, right? So we are going to benefit from what they're providing. They're going to benefit from what we pay for the food, because the marginal benefit for me is to satisfy my hunger, right? The marginal benefit for the company is the profits, right? Yeah, the revenue, the profits, right? Yeah. So we again come back to this idea of marginal benefits versus marginal costs, right? Because what I pay for that pizza or for that food is my cost, right? But in return for that, I get some benefit. I get to satisfy my hunger, right? So once we come back to this marginal benefit and marginal cost, one thing I can also kind of point out so that I build up a little bit towards our topic is the difference between marginal benefits and costs from one individual to the next. We have 20 people here. Maybe some of them are more hungry, some of them are less hungry, right? Some had a small breakfast, some had nothing for breakfast, some had pretty good breakfast, right? So if we just share the 10 slices of pizza among 20 people equally, half a slice each, right? It's pretty good, right? Kind of hard to argue against that, except that maybe Francis is ravenous because he hadn't had breakfast and actually skipped dinner last night also, right? Whereas somebody else over there had a nice breakfast. They wouldn't mind half a slice of pizza because, I mean, how can you say no to pizza? It's impossible. Really, I mean, the only thing that's impossible in the world is to say no to pizza, right? I'm just kidding, but would it be more efficient? We're talking about efficiency, right? To give that half a slice of pizza to somebody who will benefit more from that. If he's really, really hungry, he's like, I'm starving now, right? Yes? So this difference between marginal benefit and marginal cost also plays a role, okay? So we're gonna look into that. So a bit of an introduction of what we're going to do, okay? So starting with generally what it's about, allocating the resources. And there are many ways of allocating the resources. We're going to talk about the market way of allocating the resources because perhaps that's one of the better ones, okay? Perhaps it's not the best, it depends, right? But it's not the worst either, okay? It's not the worst either. As you've heard, it's kind of related to all those marginal benefits and marginal costs. Again, the comparison between benefits, right? So, to review a little bit, okay, let's have a look at this connection between marginal benefit and demand, right? We'll come to the supply as well later. But if you get that slice of pizza when you are hungry, right, you would get some kind of value out of it, right? Which is, I don't know, just some kind of benefit that you get from the goods or from the services. Let's look at these per unit, then I can transform that into marginal benefit, right? I'm just trying to connect back to what we already know. Right? And if I look at the marginal benefit, how can I measure it? The marker is getting exhausted, so I'm going to read out everything, so don't worry. I might try to measure the benefit you are getting from each piece, the marginal benefit, right? From your willingness to pay, just like the experiments I talked about several weeks ago, right? We have the first slice of pizza here, and I start bargaining with you. Are you happy enough to give me 1 NT for this? How about 2? How about 3? How about 4? And so on. At the place where you switch from willing to pay some amount to not willing to pay a larger amount, that's probably kind of a measurement for your benefit that you're getting from this first slice of pizza. I can do the same for the second slice of pizza, right? Right? So that's kind of one way of measuring the benefit from your willingness of how much you're happy to pay for that. But remember, it's kind of connected to demand as well, right? Because what is demand? It's the relationship between quantity and price, right? One way of looking at it, yes, is at a particular price, how much are you happy enough to pay, or how many are you happy enough to buy, right? But the opposite way of looking at the same function, right, is that for the first slice of pizza, how much are you happy enough to pay at the maximum? And for the second slice of pizza, how much are you happy enough to pay at the maximum? Perhaps less because you're not as hungry anymore, right? But again, it's kind of the same as willingness to pay, right? So we come back to finally kind of proving this. Yeah, marginal benefit is your demand, right? Okay, so that's kind of useful for the rest of the chapter. Okay, demand is marginal benefit. Now another subtopic. Another subtopic. I'm still within the video, I think. Individual demand versus market demand. Okay. Individual demand versus market demand. We already know what is demand, right? It's simply the relationship, just like for any mathematical function in your high school, y equals a plus bx, or a minus bx in that case, right? It's just the relationship between y and x. So demand, similarly, just the relationship between price and quantity, right? Between price and quantity for one person. Right? So we have a general idea of what demand is, right? It's just the relationship between price and how many quantities at a particular price people would be buying. I can apply that same idea for one person as well, right? So just take one person, take me, and give me a range of prices. Ask me how many I would buy at those different ranges of prices. Put the dots on the chart. That will be demand. That's specifically from me for this particular product, right? And market demand is the same relationship. I'm not going to write out everything because it's generally the same relationship between price and quantity is bought. In this case, I'm just going to say for all buyers. For all buyers. Okay. So why did we have to split this general idea of demand that we already have into individual demand and market demand? Because in trying to show what's efficiency, okay, we will try to show it by maximizing the extra value for you on top of the costs that you had to pay. Okay, so for example, if you have this slice of pizza that you acquire for 30 NT, right? It will satisfy your hunger. As we already mentioned, I can try to measure this level of satisfaction with money, even though hunger is not a monetary thing, right? But with experiments I can, right? So let's say the value of hunger that you satisfied is 100 NT, right? The maximum that you were happy enough to pay for that slice of pizza was 100 NT, but you only had to pay 30. So yay, it's like a bit of a profit for you, even though there is no actual money that you receive. You know what I mean? That kind of imaginary profit in economics is called consumer surplus. You consume something which is of great value to you, but you only had to pay less. Okay, so that is consumer surplus. And what we're going to do by looking at efficiency is we'll try to add up all the consumer surplus for all the buyers. Then there is also a similar thing called producer surplus. Okay, we add up all of that together. We try to maximize that for efficiency. If that's not maximized, then we are losing out somewhere. That's the idea. So that's why we split this general idea of demand into individual demand and market demand. Now, running ahead a little bit ahead of my lecture, we'll come back to producers a little bit later, but since I've already mentioned it, producer surplus must be kind of familiar to you. You sell something at a really good price. Let's say you sell a t-shirt for 3,000 NT, but it only costs you 300 NT to make it, right? So this difference between the price and cost, for this topic in economics, that's we're going to call it producer surplus, because we try to maximize something similar to consumer surplus. So let's just call it producer surplus, but it's also profit, right? You sold something for 3,000 NT, it only costs you 300 NT to make. So your profit is 2,700. That's producer surplus. So we'll come to that probably in the second half of the second hour of the class. But just running ahead a little bit of my slides, right? So as I mentioned, we will try to add up everybody's consumer surplus find the total consumer surplus. Then we'll do the same for total producer surplus and see what we can do about maximizing that for efficiency. Otherwise, if it's not maximized, then probably it's not efficient, right? Just like in our example, let's say we have a slice of pizza, somebody's really hungry, happy enough to pay 100 NT for this pizza, right? And somebody else is not really hungry. Doesn't mind to have a pizza, slice of pizza, but not really hungry. So a girl here is happy enough to pay 100 NT for the slice of pizza, right? Somebody else is only happy enough to pay 45 NT for the slice of pizza, right? If this pizza goes to him, right? The consumer surplus, let's say this is the only pizza that's available on this market, in this class. The consumer surplus in this example is 15 NT, right? The extra value that you got on top of paying the cost is only 15, right? So perhaps it's not really efficient, because if we instead give the slice of pizza to her, right? Then the extra value from this all exchange, we only have one slice of pizza, we don't have anything else. The extra value from this resource, the consumer surplus, would be 70, because she's really hungry. You're not really that hungry, right? So that's why we try to maximize that. If we try to maximize that, if we don't maximize that, we must be losing out somewhere, right? So this is an example to make it kind of intuitive. Okay, so now let's illustrate the individual demand and of course individual consumer surplus. So let's say we have a demand function like this. Say Alan. Quantities, prices, and let's say this is P equals 20 minus 2Q. So this of course is 20 then, and this is of course is 10, right? This is Alan's demand for, I don't know, chocolate, pizza, anything, okay? So without showing the supply, somewhere there will be a supply, right? And demand supply together will make a market price. So let's say, for example, the market price is over here, 8. Market price is equal to 8. And let's say we don't discriminate. So whether he's buying the first unit or second, third, fourth, ninth, 10th, he's going to have to pay 8, right? No price discrimination. So there should be 5, then yes, 1, 2, 3, 4, 5. So from the first unit that he buys, this is the total marginal benefit, because we know that marginal benefit equals demand, right? This is the demand function showing where is the demand. This is total marginal benefit, right? But the consumer surplus, okay, so we can have our first formula over here, okay? The consumer surplus is the marginal benefit, right, minus marginal cost. In this case, that's minus the price, because for the buyer, the cost is the price. Right? Let me correct this, because I don't want to confuse you, right? Because marginal cost will be used a lot in case of the suppliers. Here we're looking at the consumer. His cost of pizza is the price, and I don't want to confuse the buyer's cost with the cost of production over there, so too many marginal costs with different meanings. Let's just stick to price. Okay? So here it is on the chart. This is a consumer surplus from the first unit, right? When he buys the second unit, this is the consumer surplus from the second unit, right? The value minus the price. The value decreases because he's not as hungry anymore. With the third unit, the value again is a bit lower over here. With the third unit, the consumer surplus is over here of the third unit, right? And so on. Fourth, fifth, right? And of course, sixth. How many units will he buy? He will buy 6 units, right? He will keep buying until demand goes down to 8, right? Because if the value is lower than what you have to pay, you're not going to buy it, right? If the value is bigger than what you have to pay, you're going to buy it, right? So we just try to put 8 over here, find Q, it will be, I think it will be 6, correct me if I'm wrong, my arithmetic is not that great, right? But if we put 8 here, I think it's going to be 6, right? So he's going to buy 6 units over here, all of that area. of this area, okay, is the consumer surplus of Allen. Oh, it's just a simple triangle, right? So consumer surplus is also like the price at zero quantities, anyway, the maximum point of that demand, right? Minus the market price, right? Multiplied by the quantity of this particular individual's choice. And divided by 2 because that's a right triangle, right? It's a 90-degree triangle, right? So if I multiply this by this, it will give me the area of this rectangle, right? But this is only half of that. Divided by 2, that's the formula for the area of a triangle, right? We can actually say how much exactly it is in this case, right? For Allen, the consumer surplus is going to be equal to 20 minus 8 times 6 over 2. That's that's 12 times 3 is going to be, I think it's going to be 36. Correct me if I'm wrong. Let's have one more example. It's getting better because we are getting used to using these formulas. Let's just have one more example. Bob, so A, B, quantity, price. Bob's demand function, for example, is, let's say, 10 minus Q. 10 minus Q, right? What are these numbers? Can you guys tell me? This and this. I think it's 10, and I think it's 10. Yes. Because if I put 0 here, this must be 10, right? 0 for the price, because over here price is 0, this must be 10 then, right? Okay, the price is 8. The price is over here. His consumer surplus is over here, so let's show that. That's consumer surplus for Bob. How many units is he going to buy? 2, exactly. So how much is Bob's consumer surplus? 10 minus, this is the price of 8, right? 8 times 2 divided by 2, that's 2. Right? Good, this is the thing that we will try to maximize a bit later. But before we do that, let's learn to add up their demands to go from individual demand to the market demand. Okay. So what do I have here? P equals 20 minus 2Q, and P equals 10 minus Q. So if I add up, P equals 30 minus 3Q, is it? No, we cannot add up like that. Unfortunately, it would be very easy. Very easy, but it doesn't work like that. Because nobody's going to pay the price of 30. Because the highest that this guy is happy enough to pay is 10, right? The highest that the other guy is happy enough to pay is 20. Nobody's going to pay even the price of 21. So at the price of 28, this function says there will be some purchasing, but there won't, right? So we can't just add up like that. Cannot just add up like that. And you also can't just say, oh, you forgot to add the 2 p's together, then divide everything by 2, that's 15, and this 1.5 or something. It doesn't. It's also not correct, because the maximum price is not 15. Somebody will be buying at 19. One of these 2 people, Alan and Bob, will be buying at 19. But this says no buying at 15, right? So it's not like that we add up individual demands into the market demand. So how do we do that? That's our next subtopic. It's pretty tricky. Not very tricky, but it's a big part of this chapter. So adding individual demands into market demand. How do we do it? We basically add the quantities horizontally for the same price, because the prices wouldn't change. The highest that Alan is going to have enough to buy at is 20, not more. And for Bob, whether he's the only buyer or he's together with Alan, Alan's choices don't affect Bob's valuation. The highest he's happy enough to pay is 10. When the market price is 13, only Alan will be buying. Bob is not going to be buying. When the price is 8, both are going to be buying. Okay? So for the same price, we just add things horizontally. Okay? So how we're going to do it? Let me erase this so I need more space. Okay, so that's Alan, that's Bob. So for him we had 10 here, yes, and the same 10 here. Okay. And let's have a market here. Let's say we have a small village, only 2 buyers of pizza. Okay. So we could choose a range of prices here. We could choose a range of prices here. Let's choose 20, 15, 10, and 5. Okay. So at the price of, okay, I was going to start with 5, but let me start with the easiest one, which is 20. At the price of 20, how many slices will Bob buy? Yeah, Bob, at the price of 20, how many slices will he buy? 0, right? And at the price of 20, how many slices will Alan buy?
1.
Let's put the function P equals 20 minus 2Q, right?
Yes.
So if this is 20, this must be 0, right? It's starting right here, right? But yeah, I mean, your point, I understand your point. Sometimes it's kind of tricky to go like from continuous function into like chunky functions that we're actually looking at here, right? Because when I was talking about the consumer surplus, right? What do you mean by that? Where exactly is it? Right? Does it go all the way to 0? From 0 to 1? Right? Because like I either get the first slice of pizza or I don't. How come the benefit is already decreasing here within the fractions of slices of pizza?
Yeah, because they don't sell half pizzas.
Yes, so your point, that's correct. It's kind of tricky. Yes, it's kind of tricky. It is kind of tricky. So the best way to do it here would probably be going into differentiation. It's like looking at the slopes with limits, right? Because differentiation is kind of derived from limits. It's kind of a pretty tricky math there, right? So we're not gonna go there just for simplicity. Let's just use this formula, right? It's not ideal because he's gonna buy 1 slice of pizza when the price is 18, right? How about if the price is like 18.5? He's above 0 here. right? So yeah, your point, I get your point. It's kind of tricky here, but let's just stick to this formula. So let's say at 20, he's, let's say not going to buy anything, right? So 0 plus 0 is 0, right? At the price of 15, how many slices will he buy? It's tricky. It's fractions of slices, yes? Okay, even if it's fractions, let's just do it. At the price of 15, how many slices is he buying? 2.5, right? Let's say they slice the slice into halves, whatever. So he's going to buy 2.5. How many slices will Bob buy at the price of 15? 0 plus 2.5 is, I think it's 2.5. Okay. So at 20 we have 0. At 15, right, we have 2.5. Let me put the scales here. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's the max I need, because together they're going to buy not more than 10 anyway. Okay, so he's going to buy 2.5 at the price of 15. So that's somewhere there. Actually, right, I could also do it for price 16, 14, perhaps it would be easier, I will not have fractions here, but actually, anywhere between the prices of 20 and 10, who is going to buy anywhere between the prices of 20 and 10? A or B? Only Alan is going to be buying between the prices of 20 and 10, because Bob will only start buying at the price of 10 or lower, right? So actually, in this particular village of only 2 people, right, the whole market demand anywhere above the price of 10 only consists of Alan's demand, right? So with this logic, I can just copy this section of the chart and put it here. It looks a bit different because I've stretched the horizontal axis so we can see the details, right? So from 20 all the way down to 10, okay, all of these are the same. If this is the same, I can just use this as a straight line. I just need to find this point over here, right? Which is, I think it's 5. Right, it's 5. So let's go up to 5. 1, 2, 3, 4, 5. Right? At 10, we have 5. Like that. Okay. Now, below the price of 10, Bob is going to jump in as well. At the price of 10, he's still buying 0. So this point is still the same as Alan's point over there with a question mark. But below, at the price of 5, for example, Alan is going to buy 7.5, right? At the price of 5, Alan is going to buy 7.5. Bob, at the price of 5, is going to buy 5, yes. Together, that's already, I think it's 12.5, right? So 6, 7, 8, 9, 10, 11, 12.5, so somewhere here. So at the price of 5, it's kind of not straight. We have a point over here. Going all the way down to 20. Because at the price of 0, one is going to buy 10, and another guy is going to buy 10, that's going to be 20, right? Not good. Not great. Looks like a straight line, but it shouldn't. So that's why I'm saying not great. The way I stretched it, I guess, it's not really consistent. I don't have a ruler. It should look something like this. It should look something like this. Going straight until 10, then a break. Change of slope. All the way down to 20. It should look like that. Because at the price of 10, one more buyer is jumping in. So with additional decrease in quantity, the horizontal additions of with additional decrease in price, sorry, with additional decrease in price, horizontal addition in quantity is now greater, right? Because we're adding the quantities horizontally. That's how it should look like. Okay, not so great. Let's have one more. Yeah, one more example, I mean, different example. We still have a bit of time, maybe. Okay, let's leave these guys so I don't have to recreate too much. Same function, okay. Let's just add someone else here. Someone else here with that's Carol with the demand equal, let's say 24 minus 2q, something like that, let's say. Right? So it's going to look like this. That's 12. This is going to be 24 somewhere here, I think. Call it 11, call it 12 here. So now when I add the quantities horizontally, in the price range between 20 and 20, in the price range between 24 and 20, only Carol is buying, right? So that market demand is going to be the same as Carol's demand. From 24 down to 20, this section is only Carol buying, it's identical to Carol's section. Whatever the quantity is here, maybe you guys can work out. I think at the quantity of 20, I'm sorry, at the price of 20, she's going to buy 2. So in the price range between 20 and 10, 2 people are going to be buying, Alan and Carol. Okay. So from 20 to 10, 2 people are going to be buying, so one more buyer jumps in. So with one more buyer, the horizontal additions are going to be larger. So there's a break over here in the demand curve. Okay, going to go down to the price of 10. Okay, and below the price of 10, a third buyer is jumping in. Right, more additions horizontally. Right, as we keep going down the price, additions horizontally become bigger because the third buyer jumps in. Another break over here. So steep, less steep, less steep. Right? Another break over here like this, all the way up to how much?
24.
32, because 3 people together. If it's free, the first 2 guys are going to get 20, the Carol is going to get 12, that's 32, I think. So another case, how about we have something like this? If we have 3 people in this small village, but their demand curves look like this. One guy is happy enough to buy at a high price B, and the other 2 are only jumping in at the same price A. How many breaks are we going to have on the only one break? So the number of breaks doesn't have to be the same as the number of buyers in the market. The number of breaks is the same as the number of prices that bring new buyers. So in this example, for example, right, in the market demand, we're only going to have 1 break. Between A and B, this is identical. Below A, there's only 1 break, and there's no other price that brings new buyers later. So number of sections of the demand is not the same as the number of buyers. Okay. Instead, number of breaks is the same as number of new prices that brings new buyers. Right? And now let's say the price is 8. Right? How much is the consumer surplus? I'm talking about the market consumer surplus. So it's all of this area, right? Right? Perhaps it's easy to split it into sections. I know the prices, right? I know the quantities. This is 2. This is 2 plus at the price of 10. This guy at 10 is going to buy 6, right? If this is 10, I think this should be, or 7. 7, yes, 7. 7. If this is 10, this is 14, yeah, 7, right? And at 10, this is 5. So 5 plus 7, 12, so this is 12, right? So basically we have 1, 2, 3, 4, 5 shapes. Rectangle, rectangle, and 3 triangles, right? We can find the total consumer surplus, right? It's equal to 24 minus 20 times 2 divided by 2. That's one small triangle over there, right? Plus that rectangle, this rectangle, 20 minus 10 times 2 plus, right? This triangle, 12 minus 2 times 20 minus 10, that's the height of the triangle, right? Divided by 2, plus this rectangle, 10 minus 8 times 12. And lastly, plus this last triangle, right? This last triangle, 10 minus 8 times this length. At 8, how much are we buying? How much are we buying at 8? At 8, we have 6 here. At 8, we have 2 here. And at 8, we have 24 minus 8 is 16. Divided by 2 is 8. Yeah, so that's also 8. 5 plus 2 is 7 plus 8 is 15. Huh? Ah, yes, thank you. Then 16, right? So that's 16 over here. Okay. I was looking at the last triangle. Okay. This height multiplied by this base, right? 10 minus 8 is the height. Base is 16 minus 12 divided by 2. So all of this sum is a total market consumer surplus. Okay? So it's kind of time consuming. It is a little bit kind of tricky. Not very tricky though, because it's all like high school simple math. Right? It's just that you probably have to repeat the same procedure several times. Questions?